Hey everybody, welcome to the 3.1 notes covering scatter plots and correlation. So with this being 3.1, obviously that means we are starting chapter 3. In our previous chapters, what we'd have is one set of data, and we looked to analyze it a variety of ways. Measures of center, measures of spread, outliers, looking at graphical representations of them. What we're going to get into in chapter 3 here is now instead of looking at one set of data and doing an analysis there, what we're going to do is we're going to have two independent sets of data and then see how do they relate to one another. So as we go through, you can see our learning targets. One, we want to be able to distinguish between an explanatory and a response variable. Two, we want to be able to make what's called a scatter plot to display the relationship between two quantitative variables. Three, we want to describe the direction, form, and strength of a relationship displayed in a scatter plot and identify any unusual features. Four, we want to be able to interpret correlation. Five, understand the basic properties of correlation, including how the correlation is influenced by outliers. And lastly, distinguish correlation from causation. We are only going to focus on these first three in this video, and then the next video for part 2 will be covering the last three learning targets. Now, before we even get into this lesson, it's crucial that we have a general understanding of these little components here. First, when we talk about statistical relationships, we are talking about overall tendencies, not exact rules. So when we talk about the relationship between two variables, typically as this goes up, so does this. Typically as this goes up, this goes down. Okay, but there's no guarantees. So that's one thing we want to keep in mind. These are just general tendencies, not specific rules. Second, a relationship between two variables does not necessarily equate to cause and effect. Two things can be related, but that doesn't simply mean that the first causes the second to occur. So we want to make sure that we are clear on that. And lastly, the relationship between two variables can be strongly influenced by other variables that are lurking in the background. What this seems or says is that there may seem to be a relationship between A and B. However, there really isn't a relationship between A and B. We've got C going on in the background that's actually influencing both A and B simultaneously. So we'll take a look at some examples of that later on in this lesson. Okay. Now, first I want to apologize because typically this is a fun activity where I provide free candy for everybody. If I'm feeling up to it, maybe I'll bring it back for you when I return. But basically the way the activity would go would be you use your dominant hand, you measure the hand span from thumb to tip of the pinky in centimeters. Then I'd have a big bowl of candy. You reach in and see how many pieces of candy that you grabbed, and we would record those two variables. However, because we cannot do that, we actually have to revert back to our COVID protocols when we did this lesson, and we're going to measure height in inches as well as shoe size. But in order to convert, because shoe sizes for males and females differ, the girls are going to subtract their 1.5 off of their shoe size in order to convert. Now, unfortunately, we do not have the ability for me to collect all of your data. So what we're going to do instead is I'm going to take data from last year. And here's our dividing line right there. And I'm going to ask that at this time we pause the video so that you can get each of these values recorded. Okay, so go ahead and pause the video. Okay, now what we have here are two sets of data. We have the height of various students in inches, and we have their corresponding shoe size. What's important to note is that this height of 71 corresponds to this shoe size of 11. Likewise, this 60 inches corresponds to this 4.5 or 4.5 shoe size. Whenever we have our two sets of data that are being collected from the same individual, we want to make sure that we align those accordingly so that way they match up. Now, in this particular case, or in any case in which we're working with our bivariate data, we have what's called an explanatory variable and we have what's called a response variable. The explanatory variable is also the independent variable. It's the variable that helps explain or influences changes in the response variable. Whereas the response variable, also known as the dependent variable, measures the outcome of a study. Okay, with the key word there being the outcome. It's the result. Okay. Now, one thing to note is that a change in the explanatory variable does not necessarily indicate a change in the response variable. So what that means is, for example, I'll just highlight it here. We had two students, one who was 69 inches and one who was 71 inches. So obviously there's a change there in one variable. However, there was not a change in their corresponding shoe sizes. Okay? So just because one value changes doesn't necessarily mean the other does. Okay? So in this example here, it asks us, in the opening activity, what was the explanatory variable and what was the response variable? So what we want to ask ourselves is, does the height of a person help express the or explain the shoe size of a person, or does the shoe size influence a person's height? Okay, so hopefully we have that understanding that however big your foot isn't going to influence how tall you are, but rather vice versa. How tall you are will influence the size of your foot. So in this case, our explanatory variable is height, whereas our response variable is shoe size. Okay. So now what I'm going to ask that you do is I want you to just do a little brainstorming on your own. See if you can come up with an example of an explanatory variable and a corresponding response variable for that explanatory variable. Okay, when you have an example, write it down. So some common ones here would be height and weight, or height and shoe size is what we have. Height and weight is another common one. Typically, your height will influence how much you weigh. Another example could be something like years of schooling and annual salary. Okay, typically, the amount of time you spend in school, the amount of years you spend in schooling, will influence the amount of money that you make. So there's just a couple quick examples. Now, a scatter plot is the graphical display that we use when we have these two sets of data. So by definition, a scatter plot is a graphical display that shows the relationship between two quantitative variables measured on the same individuals. So in this case, both the height and the shoe size were measured on the same individuals. So the explanatory variable is going to appear on the horizontal axis, labeled and scaled. The response variable is going to appear on the vertical, didn't even realize that, axis, once again labeled and scaled. And then lastly, each individual is represented as a point on the graph. So in example 3 here, it says to create a scatter plot showing the relationship between, we want height and shoe size. So when I create my scatter plot, I'm going to make my two axes, my horizontal and my vertical axis. My horizontal axis is the explanatory variable, which we said was height, and that's going to be in inches. Now, as I go and I look at our height in inches, I can see that the smallest looks like it's going to be 60, which it is. And the largest, I see 71, 73. Okay, 60 to 73 is going to be our range of values. Now, I'm not going to start at 0 at the origin, so I'm going to put that double slash there. Okay, and I'll go 60, 62, 64, 66, 68, 70, 72, 74. When it comes to shoe size, looks like our smallest shoe size is 4.5, and our largest is 12.5. So if we come down here, we label our vertical axis. Then our biggest shoe size was 12.5. So let's just maybe say this is 14, 7. Nah, I don't like 14 and 7. 16, 8, 4, 12. And then from here, we just simply plot each individual set of data. So 71 inches, shoe size of 11. 71 inches right here, shoe size of 11 right there. So that is that individual. Okay. And you don't have to put coordinates each time, but I just like to show it for at least one, just to show that that's one of our individual values. Okay. The next one is going to be the person who has a height of 70 and 10.5 for their shoe size. So 70 right here with a 10.5. Right here. And we could continue to do this over and over and over again. Okay. If you are ever asked to make a scatter plot by hand, you will not be given this large of a set of values because obviously it takes time to do so. So instead, one of your options is you could take this data and you can put them into two separate lists. List 1 and list 2. Okay. So list 1 is going to be your explanatory variable. List 2 is going to be your response variable. Very, very important that you make sure that each data value corresponds for their matches individually. So for example, again, the person who was 71 inches tall needs to have a shoe size of 11, and that's what we have here, 71 inches tall. Next to that is its shoe size. So at this time, please pause the video and take the next 30 seconds to put your height into list 1 and put your shoe sizes into list 2. Okay, perfect. Now, once you have that data into list 1 and list 2, you're going to go second, quit, back to your home screen. And just where we do all of our other graphical displays of data, we're going to hit second, y equals. Make sure plot 1 is turned on. And then the very first type you can see is just a series of increasing dots. That is our scatter plot option. As you go down, your X list, okay, this is your explanatory variable list. Where is it? It's list 1. Your Y coordinates, that's going to be list 2, the response variable. Second, quit to go back to your home screen. Zoom, option 9. Of course, an ad would pop up, so let's go ahead and fix that. Zoom 9. And sorry about that. I forgot the box plot was there. There we go. So there is our scatter plot. So what you can do from here is just a rough sketch in terms of what this looks like. Okay, you don't need to account for every single point. You don't have to make sure that everything is exact to scale if you are asked to do this for the AP exam and you have a large series of dots or a large series of points. So again, what we saw is something where we've got just above 4 at 60, 2 points, 1 slid over at 61, okay, a little bit higher, 1, 2, 3, 1, 2, and then up higher, here, here. And so there is our scatter plot. Okay. Again, typically it's going to say sketch a scatter plot, but more often than not on the AP exam, you are not going to make a scatter plot. You are going to have to analyze one. Given the scatter plot, answer this, answer that. Okay. So one of the most common things that you'll be asked to do with a scatter plot is to describe the scatter plot. So when we describe a scatter plot, just like when we described a distribution, there were 4 things. When we describe a scatter plot, there are 4 things. When we had to describe a distribution, it was shape, center, spread, unusual features. When we describe a scatter plot, the 4 components are direction or association, form, strength, and unusual features. So the direction option is positive, which means as x goes up, y goes up. Or it could be negative as an association, which means as x goes up, y goes down. Okay. So the direction is positive if our dots are increasing as we move from left to right. As x goes up, y goes up. A negative association would mean that the dots are lowering as we go from left to right. As x is getting bigger, y is getting smaller. Now, we always want to include context when we are describing the direction or the association. Okay, and you'll see what that looks like in just a moment when we do an example. Okay, our form is either going to be linear or nonlinear. Do the dots appear to follow a straight line pattern, linear, or do they have more of a curved pattern to them, nonlinear? Next, we have the strength. Okay, how strongly do these 2 sets of data appear to be related to one another? And the more linear or the closer the dots are aligned to a pattern, the stronger the relationship. Whereas the more spread out the dots are, the less. So we have words of weak, moderate, and strong. So a weak relationship would look something like this. The dots are spaced out. We really can't tell if it's positive or negative. Okay, there just doesn't really seem to be an association between them. Whereas a moderate relationship, we're going to start to see a pattern, but there's still some space between the dots. Something like that, where we can see this general upward pattern, but we can see that the points are still kind of spread out from one another. Whereas a strong relationship, something like this. The points are very, very condensed towards a straight line. Okay, so that would be a strong relationship. And then lastly, our unusual features, just like before, are going to be any points drastically different from the overall pattern. So those are our unusual features. Any points drastically different from the overall pattern. So as our AP exam tip here in yellow, when asked to describe the association of the scatter plot, you are expected to address direction, form, strength, and any unusual features in the context of the problem. Okay, so let's take a look at what that looks like here in example 4. Describe the scatter plot that shows the relationship between hand span or height and candy grabbed or shoe size. So in our example here is our scatter plot. We want to ask ourselves, first and foremost, what is the direction? So hopefully we can see that the direction is positive. If I drew a line to look at that, that's kind of what we would see. Okay, so it is going up from left to right, so the direction is positive. Now I have to include my context. Typically, as height increases, shoe size also increases. That's my direction. For form, it appears as if we are following a linear pattern. So we say linear. When it comes to strength, we can see that the points are following that straight line pattern, but we do have some variation here from the line, some deviation here from the line, but not terrible. So I would say this is moderate to strong, so we can compromise and we can say that it is moderately strong. And lastly, unusual features. When I look at this scatter plot, there really isn't anything way outside the norm that we've established here. So we would just say none. So when you are asked to describe the scatter plot, these are the 4 things that we want to address: direction, form, strength, unusual features. Okay, so where we're going to wrap up this video here is with example 5. So what I'll do is I'll read through the question, I'll ask that you pause the video, try this example on your own, and then resume the video when finished. So example 5. The scatter plot shows the relationship between payroll of all 30 Major League Baseball teams and the amount of wins that they had in 2019. Describe the scatter plot. So for example, this team right here spent just short of $1 million or $100 million on their payroll, and we can see that they won just over 40 games. So that's what we're looking at. So at this time, please pause the video, complete example 5, and resume when you are finished. Okay. So first thing we address is the direction. Once again, we can see that the overall pattern seems to be increasing. As X goes up, we can see that the points are going up. So positive. Typically, as teams spend more money, they win more games. Okay. As far as our form goes, we don't really see a curve pattern to it. Some students will say nonlinear because this isn't condensed. But if we look at the overall pattern, it does have that linear form to it. Okay, so this is linear. But where we can address the idea that it's not very condensed is in the strength, where we can say that this would be moderate or weak, so moderately weak. And lastly, any unusual features. Okay. The one that really stands out to me is this one right here. This is a team that spent just over $50 million and won over 70 games. So, unusual features. One team spent little money and we can say just over 50 million. But won over 70 games. And there's our description of a scatter plot. So, through this video, we should have been able to do these three things. 1, distinguish between an explanatory variable and a response variable. 2, make a scatter plot to display the relationship between two quantitative variables. And 3, describe the direction, form, and strength of a relationship displayed in a scatter plot and identify unusual features. Okay. As always, if you have any questions, please feel free to reach out, and I'll do my best to get back to you. Otherwise, thank you for watching, and have a great day.